Welcome to our instructional video on the PEI crop rotation calculator. The concept of the calculator emerged from collaborative discussions and on-field visits involving living lab scientists, the PEI potato board, and local potato growers. The inspiration came from a pivotal encounter with a PEI potato farmer who was utilizing a yield monitor on his tractor. This technology allowed the farmer to measure harvest yields across different parts of his field. During one harvest in an area where potatoes hadn't been planted for more than the conventional 3-year cycle, the farmer noticed a remarkable finding. The yield numbers on his monitor showed a significant increase, almost double their typical yield. Potatoes and PEI demand substantial resources, especially inputs like fertilizers and pesticides. So the unexpected high yields observed after an extended break from potato cultivation prompted the farmer to contemplate the potential benefits of exploring non-traditional and longer crop rotations. Such rotations could not only sustain profitability, but also reduce pesticide use and enhance soil health across his farm. This observation sparked further investigation by scientists at Living Labs Atlantic and the PEI Potato Board, alongside ongoing discussions with growers. Their collective efforts focused on exploring the economic and environmental advantages of different crop rotations, leading to the development of the crop rotation calculator. This tool is specifically designed to assist potato growers in PEI in planning or exploring alternative crop rotations. By helping to inform decisions on which crops to rotate and determining optimal intervals before replanting potatoes, the calculator can help growers enhance soil health while increasing crop yields on their farms. So join us as we demonstrate how this calculator can be used to help support economically effective farming decisions that could benefit both your farm and the environment. The purpose of the calculator is to help potato growers decide if longer crop rotations could be financially beneficial for their farm. It uses provincial average crop production data from recent years and lets you input details specific to your farm, like which crops to grow, costs, and how much yield is produced. The calculator compares the benefits of sticking with the standard 2 or 3 year rotations versus trying a 4-year rotation. It considers how this choice might improve your soil health, reduce pesticide application, and boost overall crop productivity. Keep in mind, the results are based on provincial averages, and each farm is different. So it's important to adjust the relevant preset values in the calculator based on your farm's unique conditions, like your local climate and soil type. For personalized advice, consult with local experts and make sure any changes you consider follow PEI's agricultural regulations. Remember, this tool is meant to give users insights and ideas, but it is only one tool, and there are many considerations that will need to go into individual farm crop rotation decisions. In the next few slides, we'll explore the layout of the calculator and go through how to use the tool, with 2 different hypothetical examples that can help users, like yourself, to make decisions about your farm's crop rotation strategies, aiming for better sustainability and profitability. In terms of organization, the calculator consists of 6 tabs. The first being the Introduction tab, which acts as a landing page. It provides background information, clarifying the purpose and benefits of the calculator and agricultural practices. It also talks about the organization of the calculator and what to expect from each tab. Assumptions are also outlined, along with a discussion about the calculator's scope and accuracy. We seek to be transparent about the underlying assumptions used in developing the calculator and to outline what the calculator can and cannot do. Disclaimers further reinforce this by highlighting any limitations or conditions under which the calculator may not be suitable. So we highly recommend that you read through this. The landing page also provides a clear representation of cells to guide users in inputting data, helping to reduce any errors and enhance result accuracy. It also offers detailed crop selection instructions, so users can either select crops from a predefined list or input custom data tailored to their specific farming scenarios. In addition, A comprehensive list of abbreviations, definitions, and calculations are also provided to help users interpret technical terms and better understand agricultural practices and outcomes reflected in the calculator. For instance, concepts like net present value or NPV are explained to help users assess the profitability of an investment by accounting for factors such as interest rates and inflation. A positive NPV indicates that the investment is expected to generate more money than its costs over time. Another key concept is discount rate, which determines the present value of future costs or revenues. It helps answer questions such as, if I could receive $100 today or $110 from now, which would be more beneficial, by factoring in the changing quote unquote real value of money over time. The inflation rate reflects how much prices typically rise each year, affecting the purchasing power of money. For instance, if inflation is 2% annually, something that costs $100 today may cost $102 next year. Lastly, the inflation adjusted discount rate helps users gauge how much return is needed on their investment to stay ahead of rising prices, ensuring that their returns keep pace with inflation over time. The second tab, entitled Crop Combinations, is an optional tab. It acts as a sandbox, allowing users to explore different combinations of crops to help in determining which mix of crops can make the most profit over different rotation lengths. Please note that the calculations for different crops in this tab are based on preset values found in the Crops tab, which we'll get into in a minute. There's also detailed steps at the top of each tab to help users navigate how to input or choose values. Now, moving on to the table. The table displays combinations you want to compare in each year in the 2, 3, and 4-year rotations. For column C, labeled Dashboard Crop Combination, these crops can be selected in the Dashboard tab, which we'll get to next, and compared on this tab. However, under columns E, G, I, and K, labeled Alternative Crop Combination 1, 2, 3, and 4, these crops can be directly selected on this tab and compared through the drop-down menu, as you can see here. And the chart below allows you to look at the net present value, which is the sum of projected earnings over the 12-year cash flow period from the different crop combinations that you select for the 2, 3, and 4-year rotations above here. And this allows you to see which options are most profitable. Within the chart, green represents 4-year rotations, blue represents 3-year rotations, and light brown represents 2-year rotations. And this could also be found here on the legend. But we'll delve deeper into the economics of the crop combinations and rotation lengths in the next tab. The Dashboard tab is the third tab in the calculator and is the central hub. It displays results for multiple other tabs, and it's linked to the Crop Combination tab we just explored, as well as the Crops tab and Comparison tab, which we'll get to shortly. Here you select the crop combinations for each rotation year, analyzing how different rotations and lengths impact economics and pesticide use. The dashboard provides insights into projected earnings diversification, so expected income from diversifying crops, cumulative annual earnings, so total yearly earnings, and cumulative pesticide application, so total pesticide use over time. Similar to the crop combination tab, step-by-step instructions are located at the top. Now let's walk through this tab briefly. The main tab allows you to choose crops for each rotation year from the drop-down menu. Demonstrate. You can choose your selected crops through each drop-down menu. And once all the crops are selected, the expected earnings for one complete cycle will be calculated right below in cells C37, D37, and E37. These calculations use preset costs and revenues for each crop, but if these values don't match what you expect for your farm, you can easily adjust them in the Crops tab because, as I mentioned, there are lots of customization features built into the calculator. Now, that being said, the most beneficial cycle representing the highest net present value over 12 years is shown in cell F62. The specific calculations used to determine this aren't displayed on this tab, but you can find them in the comparison tab. This table also displays the average revenue cost ratios for each crop appearing in cells F33 to H36. These ratios can vary based on assumptions such as crop yields, which you can adjust in the comparison tab, and we'll go through in one of the hypothetical scenarios in a minute. The dashboard tab also includes a graph on projected earning diversification, which allows users to visualize how much of the total projected earnings come from each crop that they selected in the 2, 3, and 4-year rotations above. And each bar represents a different year. Blue for year 1, orange for year 2, gray for year 3, gray for year 3, and yellow for year 4. The size of each bar indicates the proportion of total earnings expected from the crop. Now, if a crop doesn't generate profit, like forage, which is in year 4, and we selected in our 3 and 4-year rotations, it won't be shown on the graph because there's no earnings for those crops. Now, the final graph represents two sets of data: projected cumulative annual earnings, which are total yearly earnings, and pesticide application counts. The left axis shows the total earnings expected each year over the next 12 years based on the crops chosen above and assumptions entered into the comparison tab. This includes variations in annual crop yields and the use of agrochemicals over time, while the right axis displays the projected total number of pesticide applications over the next 12 years, also based on the chosen crops and assumptions made in the calculator. The fourth tab is the crops tab, where you can view the net operating income for each selected crop. This includes revenue from farming, variable costs, non-variable operating costs, expenses, and pesticide costs for crops such as potatoes, barley, buckwheat, corn, forage, mustard, oats, soybean, and both spring and winter wheat, which you could see all across here. Similar to the other tabs, the step-by-step instructions can be found at the top, and users are encouraged to review the notes on this tab as there are specific considerations related to these crop values. For example, the values for barley, spring wheat, winter wheat, and oats are based on harvesting grain only. However, if users want to consider the values for the combination of grain and straw for these crops, they can be found in the reference tab, which contains supplementary data for several crops, and I'll show you this in a minute. Now, with regards to the table, the initial preset values for each crop are listed in white under their respective columns. However, users can also customize these values based on their experiences by entering new ones in the adjacent checkered cells. And once the new values have been successfully entered, the cell will turn orange with a green check mark. For example, if we were going to look at potatoes, marketable yield, and if we wanted to change that to 0, you'd enter it in, then cell would turn orange with a green check mark. And you would also see the adjusted values will appear in green under the final values column to the left-hand side. Additionally, there are columns labeled custom crops, as you will see across the top: custom crops 1, 2, 3, and 4. And these are crops that aren't covered or in the crops tab or listed in the reference tab, and the data from the crops tab. So basically, these are values that you can input. These are different crops that you can input, and you can also input different values for the crops. And the data from this crops tab actually feeds into the net operating income in the comparison tab, which we'll discuss next, and the calculations in the dashboard. So it is really important that users review these values and adjust them based on their personal experience and knowledge. Now let's explore the comparison tab. The comparison tab is the fifth tab in our crop rotation calculator, and this tab allows you to compare each rotation scenario from the dashboard over a 12-year period, generating the results displayed on the dashboard itself. As always, just the instructions can be found at the top of the tab. And it's important to note that the results in the dashboard can be modified through this table to include various assumptions, including changes in pesticide use, fertilizer application, and crop yield specific to each rotation. If you'll notice by default, all of these values are initially set to 0% change, and users can adjust by entering plus or minus percentages based on personal observations and experiences, as they do vary from farm to farm. For instance, if you plan on using a nitrogen fixing crop before planting potatoes to boost yield, you can input an increase in crop yield found in row 54 here and a decrease in fertilizer inputs in row 39, 45, or 48. And these adjustments affect the net operating income table below, which consolidates data from the previous crops tab. And it's crucial to review these dollar amounts and the rates used to calculate NPV. So you'll see this here, and that includes the discount rate and inflation rate, which we mentioned in the introduction tab. And if these rates are inaccurate, you can always modify them by entering percentages in the designated checkered cells. And sorry, these values from net income, essentially from net income to revenue cost ratios, contribute to the results in the dashboard. And the customization features on this tab are important because they do help ensure that the calculations in the dashboard reflect the specific realities of users' farms. And the last tab is the reference tab, and it complements the crops tab by offering suggested values for harvesting grain and straw from barley, spring wheat, winter wheat, and oats, as well as silage from corn. And it provides data on expected yields, nutrient requirements, costs, and potential earnings that users can input into custom crops columns C, D, E, and F in the crops tab. These figures also act as default suggestions for users that may not have specific values tailored to their operation. And these default values have been compiled from a variety of sources, including provincial crop production data from government reports in Prince Edward Island, Saskatchewan, Manitoba, as well as Stats Canada and OMAFRA, which is the Ontario Ministry of Agriculture, Food and Rural Affairs, as well as other relevant resources. And if you notice, the reference tab also includes a list of helpful resources that informed or are referenced throughout the calculator. So you can find all of that information here.